Hello and welcome to chapter 8.2, and I will be doing problems number 13 and 15 in this video because they are basically the same. They're just like problems 9 and 11. The only thing is I had to turn the paper and I couldn't fit them all on one page, so I'm doing two videos for them. So in this we are again asked to find a formula for these trigonometric functions. So here we have a graph, which I have labeled f of x, just to give me something familiar, because I don't like working with y's anymore. So we have f of x, and first off we need to find the amplitude. And we have here this little midline that's drawn in the picture for us that this is oscillating between. So we can go ahead and assume this is the midline at 4,000. We also can know, because this is maxing at 8,000 and troughing at 0, and divide that by 2 and we get 4,000 anyway, just to prove it to ourselves. So we have here, oh, we're not doing amplitude, I'm sorry, we're doing midline. We are doing midline. Midline at y equals 4,000. And the amplitude takes 4,000, from starting at the midline, it takes 4,000 to get to the max, and it takes 4,000 to get to the minimum. Our amplitude is 4,000. And our period. So, looking at this graph, we start at 0, and we have increments labeled in 30s. But we can also, if we wanted to, we could come into the middle, into these little half spaces between every number, and decide these would be 15 between these numbers. So this would be 15, this would be 45, etc., etc. So I probably actually didn't even need to note that. But now for the period, let's see, for it to complete one cycle, it takes 60 units. So t equals 60. But as we know, we can't really use period in a formula. We need to convert this into b. So b, whoopsie, t equals 2 pi divided by the absolute value of b. So we know that bt equals 2 pi. I just don't want to write values in yet because I'm tired. B equals 2 pi over t. I'm going to go ahead and plug in 60 so we have our b value, and now we have everything we need to write this equation. We just need to decide whether or not we want to use sine or cosine. By now I imagine you already know we want to use sine because it looks already like a sine curve. So f of x equals, and we're going to put down 4,000, our amplitude, times sine of our b value times x. So 2 pi over 60 x. Close that parentheses, and this is actually going to get in the way, so I'm going to go ahead and erase this. and plus our midline at 4,000. And let's see, is this correct? Yes, this answer checks out. So this is our answer for number 13. So now let's come number 15. This one's not so apparently obvious at first. I sort of stared at it for a few seconds wondering, how do I do this? It doesn't really feel like there's enough information given to do it, but there is. Yeah, there is. So, first of all, let's actually start with the amplitude first this time. We see that it maxes at 4, right? It maxes at 4, and the minimum is at 0. So, we know that in between here is a distance of 4. Divide that by 2, and we have our amplitude. So amplitude equal to 2. But so is the midline, because also the same logic, the same reasoning here, since we're working with a minimum of 0 and a value that is not 0. That'll give us both our amplitude and our midline when we divide by 2. So it's easy enough. We also can conclude that the midline is at y equals 2. And now we just have to find the period. Now this is a little bit trickier, and at first, at least for me, maybe for you it'll be a little bit more apparent, but for me, it sort of stumped me for a second until I realized that we were working with sine and cosine graphs. And I don't know quite how to explain it, but if I travel a distance along this line, let's say I go r centimeters along this line, I will have the same y value as if I went r centimeters. If I went negative r centimeters across this line, I'd end up with the same y value. So I know that if I go down X amount of units to get to here, to this point here, it'd be the same amount going in the X direction if I came to this point here. And the same thing works going from here up as to here up. So we know that these in a way are sort of evenly spaced. So knowing this, I can conclude that this, at this point here, we have 6, 2. And that here, we have 3, 0. And here we'd have 0, 2. But what that also means is that here at this point, we have 12, 0. And that's important because without this point, we couldn't find the period. So now, because here, watch, I'll show you. So pretend we don't have this point here. We don't know what this x value is. That's a 2, by the way. That's a 12. Follow along, and we get here. Well, if I have 9, 4, and I don't have these other values, then I can't figure out what the period is. But knowing what we know about sine and cosine functions, we can find that at this increment at 3, this at 6, this at 9, and this is at 12. If if you don't get that and you need explanation on it, and I sort of didn't help, then let me know. But we do know, but because the reasoning I just used, we find that this period is 12. So we find that t is equal to 12. Again, I use t because physics has sort of drilled that into my mind. So now we can find out what the b value is using our t value. So t equals 2 pi divided by the absolute value of b. bt, looks like it's going to run off the camera. bt equals 2 pi, and I'll bring it back over here for you, and I'll push this up a little bit. So bt equals 2 pi. So b equals 2 pi, and I'm just going to go ahead and substitute in my value for t, 12. Simplify this, b equals pi over 6. So now we can write our formula. So we have, this is actually an f of theta, so f of theta equals, now let's see, our amplitude is 2, so it equals 2. Sine or cosine, you can see the graph, and actually I just realized I did make a mistake. Well, this graph is a little different from the others. It looks like a sine curve. The only difference is that it has been reflected about the x-axis. So it's not 2, it's actually negative 2, because we're reflecting it. So negative 2 sine, our b value is pi over 6 times theta, pi over 6 theta, and then when we flip this, so originally we reflected this across the x-axis, so before it's stretched, y will be at -1 here, then it'll be at -2, and we need to, hold up, I'm making a mistake. No, I'm not. Yeah. Y will be at 0. I was describing cosine. So at sine, y will be at 0 originally, but we need to shift it up 2. So this point needs to be here. So we need to shift this up 2 units. This graph needs to come up 2 units. So we will add 2. Does this check out? Let's check the answer. -2 sine pi theta divided by 6 plus 2. That is exactly what we have here. I just did not put theta in the numerator. I kept it as its standalone number. And that's how you do 13 and 15. I'll see you in the next video.